Lesson 10-2 of Advanced Math, Product of Powers Property. There's several properties in this lesson. This is just one of them. But our state standard says that if we're at level 3 on our standard score or scale, I can develop, use, and apply the properties of exponents to simplify expressions. We're going to work with numerical expressions, algebraic expressions, with variables, and we're going to talk powers, bases, and exponents. The product of powers property says, if I'm going to multiply powers with the same base, you just add the exponents. A to the m times a to the n equals a to the m plus n. So x to the third times x to the fourth would equal x to the seventh. And we can prove that because if I take x to the third, x times x times x, x to the fourth, 4 factors of x, together I have 7 factors of x, x to the 7th power. There's my shortcut, just add the exponents. If I have power of a power, you multiply the exponents. That means I've got a power on the outside. So a to the m to the nth is a to the m times n. So 3 to the 4th to the 5th would be 3 to 4 times 5, which is 20. It means you have 5 of these factors. 3 to the 4th times 3 to the 4th times 3 to the 4th, 3 to the 4th, 3 to the 4th. 5 of those. That's what that means. And our last power of a power, you add 1, 2, 3, 4, 5, 4, 8, 12, 16, 20, 3 to the 20th. Now, power of a product. That means I've got a product, something multiplied inside the parentheses, and if they are raised to an exponent on the outside, everybody on the inside gets raised to that power. A to the m, b to the m. We used to call this the Oprah property. It might now be the Ellen property, because if you happen to be on one of her shows where everybody gets the car, it's you get a car, and you get a car, and you get a car, and you get a car, we all get a car. And so everybody gets a power. 2 times 3 to the 4th is 2 to the 4th times 3 to the 4th. Everybody gets taken to that 4th power. Now, if I was asked to simplify this, 2 to the 4th power is 16, 3 to the 4th power is 81, and 16 times 81 is 1,296. And that would be simplified. Now, I could check that because 2 times 3 is 6, and 6 raised to the 4th power is 1,296. But this is powered out. Our next property, or here, says, how about if we just do some examples? So it says write them as a power. That means don't find me the actual answer. Same base, add the exponents. 6 to the 9th. Now this one's a little weird because here's a negative 2 to the 3rd power, but this negative 2 has an invisible 1. Everybody has an exponent of 1. So this is negative 2 to the 4th power. And because your base is negative, it has to be in parentheses. Third example, 5 to the 3rd, 5 to the 4th, 5 to the 1st. We can put that 1 in there. Add the exponents, 5 to the 8th power. Letter D, x to the 2 plus 5, 7. Here, do we have any common bases? No. So guess what? 2 to the 3rd, x to the 2nd, y to the 4th. That's as simple as I can get it. Writing with powers. Here, I have 2 that have a common base, so y to the 5th, r to the 8th. Now, as we look at our standard here, we've talked powers, bases, the exponents. Now here, we have a product of powers where we add the exponents. We have our power of a power where we take and multiply the exponents. So we've done this property and power of a product where everybody gets a power. We've done those 3 properties. Now it says simplify and write your answer again as a power. It doesn't say give me an actual numerical answer. So here, power to a power, multiply 2 times 3, 5 to the 6th power. Y to the 4th to the 6th. Is that a 6 or is that a 5? 24. 3 to the 4th to the 3rd, 3 to the 12th. Power to a power, multiply the exponents. Here we have a power of a product. This is our Ellen rule. You get a power and you get a power. 4 to the 2nd, x to the 2nd. Everybody to the 3rd, w to the 3rd, z to the 3rd. Everybody to the 2nd power. 0 and 2/10 squared, b squared, c squared. Letter D. -3 to the 4th, y to the 4th. Yes, that has to be in parentheses. Now, x to the 3rd to the 7th, y to the 6th to the 7th. Everybody gets taken to that power, but now we have power to a power, multiply. X to the 21st, y to the 42nd. And then that would be my answer. Letter F, 1/2 to the 3rd, x to the 5th to the 3rd, 1/2 to the 3rd, x to the power to a power, 15th. Now, if it asks you to leave them as powers, these would be your correct answers. If it did say simplify all the way, This would then go to 16x squared. This would go to 400ths, b squared, c squared. 81 y to the 4th, 1/8 x to the 15th. Story problem, word problem, real life. A gigabyte of computer storage is 2 to the 30th bytes. If the total storage on my computer is 32 gigabytes, how many total bytes of total storage space does my computer have? Well, every one of these is 2 to the 30th. So we're taking 32 times 2 to the 30th. Now, here's the trick. This is a power, this one isn't. But what do I know about 32? 32. 2 times 16. 2 times 8. 2 times 4. 2 times 2. 32 is a power of 2. 2 to the 5th times 2 to the 30th, which would be 2 to the 35th power. That's how many bytes of memory my computer has. And so again, we have this rule, this one, and this one, those properties that we've worked with, the powers, the bases, the exponents, and we're going to be able to use and apply those properties. So I can multiply powers with the same base. I can find power of a power, and I can find the power of a product.